Good day, everyone, and welcome to today's SecurityBoulevard.com webinar. We're excited that you've joined us. Our topic is a really interesting one: how to make the promise of machine learning a reality. Certainly very timely. We hear about machine learning all the time, so it would be great to have this topic for us today that we're talking about. Today's webinar is sponsored by ThreatStack. My name is Mitch Ashby, and I'll serve as your host and moderator. A few housekeeping items. We are recording the webinar, and we will be sending everyone, all participants, an email with a link to the recording, as well as a link to download the slides, so you'll be able to get those too. So sit back. You don't have to take a lot of detailed notes. You've got the slides. Maybe jot a few ideas down here and there, which you'll be able to listen to our great speaker today. Well, we're very encouraged to encourage you to ask questions as well. We'd love to have those questions anytime during the webinar. You can submit those and we'll fit them into the dialogue, as well as try to cover as many as possible by the end of the webinar. So let's move on to our topic: how to make the promise of machine learning a reality. It's my pleasure to introduce today's speaker, Chris Ford. Chris is VP of Product at ThreatStack. So no more delays. We're going to get right to the subject matter here. Chris, hand it over to you.
Awesome. Thanks, Mitch. And hi, everyone. Hello from rainy, cold Boston. Hope you find yourself in better climes. And I hope you're all doing well despite the pandemic. I'm excited that so many of you have shown interest in the topic for today. As Mitch pointed out, I work for ThreatStack. And if you don't know ThreatStack, we are in the cloud security business, which means we help customers with compliance and security threat detection for cloud workloads. Now, it might be obvious to you based on the topic of our webinar today, but ThreatStack has now for quite a while been down the rabbit hole on machine learning. And if you're not familiar with machine learning, don't worry. We'll spend a little bit of time today talking about what it is. If you're interested in a deeper dive on machine learning or how ThreatStack has implemented it, I've shared my email address at the end of the presentation. We love to nerd out about this stuff, so don't hesitate to reach out. But for today, we're going to talk about machine learning and some of our learnings. We'll share some tips and tricks and some best practices around how to use machine learning properly in the context of cloud security. And as Mitch pointed out, as we go through the presentation, please do feel free to ask questions. Our goal today is to help you identify very practical uses for machine learning, whether you're looking for a tool or a partner like ThreatStack, or you're looking to build your own. We want to share some of our best practices. So to kick things off, I think one of the things I want to leave you with today with respect to machine learning is what it's good for and what it's not. Certainly, there is a lot of hype around machine learning, and I think the vendor community may have done machine learning a bit of a disservice in that there are aspirations for machine learning and promises for machine learning that in some ways it hasn't quite measured up to. So as we go through the content today, we're going to look at some of those myths or misconceptions about machine learning. And we're going to talk about very practical ways that you can overcome some of those limitations so that you can really take a very focused methodical approach to how you want to use machine learning to detect threats in your cloud infrastructure. So as I said, there's lots of promise behind machine learning when it comes to security in general and cloud security in particular. And so the thing I want to start with is that machine learning is often heralded as an easy button or a silver bullet for all of your cloud security needs. And for sure, machine learning is a very valuable, very powerful tool. But it isn't magic. I know that a lot of vendors in the space sprinkle machine learning around their messaging like pixie dust, But machine learning really isn't magic at all. In fact, machine learning is math. If you're new to machine learning, essentially machine learning uses statistical analysis of a data sample to create models that then can be used to make observations or predictions about future data sets. So it's just statistical analysis of data. Said a little bit differently, you can use training sets of data. Machine learning builds models from those training sets and then uses those models to give you insights about your data. And in the case of someone like ThreatStack, this is security telemetry that we're collecting from cloud infrastructure to help you gain insights out of that data. But this is an important thing to understand, I think. Machine learning is math, it's statistical analysis. And as I like to say, machine learning doesn't make value judgments about its findings. Machine learning will identify patterns in your data. It is highly accurate, but those patterns that it recognizes aren't always relevant to you. They're neither good nor bad. And so, as we'll see when we get deeper into the presentation, there is real value in other tools and technologies, and in fact, human expertise in the loop to be able to help you understand which findings are good, which findings are bad, and which findings really are relevant to you. So machine learning is math. There's a lot of hype around the promise of machine learning, and I think a key takeaway here is that machine learning is very powerful, and we'll explore some of the ways that it can be beneficial with respect to cloud security. But it is just one tool to have in your toolbox. It's one powerful tool, and you should absolutely be thinking about machine learning when it comes to cloud security. But it's just one tool in your toolbox. There are many other techniques, technologies that can be brought to bear when searching for threats in cloud infrastructure. All right, so let's jump in. I want to talk about some of the misconceptions around machine learning, and then we'll swing around to how you might overcome some of these limitations or areas in which machine learning hasn't quite lived up to its promise. So let's do that. Misconception number one, machine learning is an easy button. Despite what you hear from vendors like ThreatStack, you can't just turn on machine learning and your job is done. And one of the things that we always talk about at ThreatStack is, a very popular mode for machine learning is anomaly detection. Anomaly detection uses unsupervised learning. So I'm gonna talk about that for a quick moment. Unsupervised learning is often a good place to get started with machine learning because when training models, unsupervised learning does not require labeled data. And there is a big scarcity of labeled data, particularly when you're talking about the volumes of data that a company like ThreatStack deals with. So oftentimes, a good place to get started with machine learning is in detecting anomalies. And anomaly detection can be used to do things like identify network connections which are not typical, or user behaviors which aren't typical, new users or new services which are at work in your infrastructure. But anomaly detection, we believe, is insufficient. But let's talk about how it's beneficial, and then we'll talk about some of the limitations. Machine learning can find patterns that humans can't. And so this is one example in which machine learning can really augment humans. You're really looking for needles in haystacks. I have a sample here of Where's Waldo. And machine learning is really good at finding patterns of interest or outliers in data sets. And I don't know if you've been trying to find them. I took far too long doing this, but Waldo is down here. in the bottom of the slide. So anomaly detection is quite powerful in terms of identifying outliers or anomalies in your data, and it can highlight anomalous behaviors of interest. But here's the rub. Anomaly detection only detects different things. Here I have a box of pencils. One of them is red, so anomaly detection would say, you know, this is an outlier. But anomaly detection finds different things. It doesn't say red pencils are good or bad. And as we'll see later in the presentation, there is some anomalous behavior which is perfectly okay, and there is some normal behavior which is distinctly not. So if you're using anomaly detection only, you're going to miss out on the normal behavior that is nonetheless very risky. We call this known behavior versus unknown behavior. And anomaly detection will detect unknown behaviors quite well. That doesn't make it bad, but it will fail to find the behavior that is known to you or quite normal. And there are examples of normal behavior which you really don't want to have happen. For example, users logging into your infrastructure as root, that might happen an awful lot, but it doesn't make it good, and you kind of want to know when it's happening. The other thing to know about anomaly detection is that something that is anomalous on day one or hour one, until once your models retrain, and if that behavior continues, it ceases to be anomalous after a period of time. So things can go from known to unknown fairly quickly. So anomaly detection does not make a value judgment, and it only surfaces what's different. So when we talk about how we overcome some of these limitations, we'll talk about the role of anomaly detection with other detection mechanisms, like a rules-based approach for identifying behaviors of interest.
Hey, Chris, before you move on, we had a really great question here from Sean that you sparked. He asks, outside of anomaly detection, what else can machine learning be used for?
Oh, sure. There are lots of great use cases for machine learning outside of anomaly detection. A few that come to mind, one would be context. If you are investigating a finding, whether it's an alert that's generated based on a rule or an anomaly that's detected by machine learning models, machine learning can be really effective in getting context for you to help with that investigation. If you're to start to use supervised learning for anomaly or for machine learning models get better and better over time when users interact with them. So as an example, user actions like I want to suppress this alert, or I want to dismiss this finding. Supervised learning can help your models get better and better, so the findings over time get more relevant to you. And finally, there's definitely a role for machine learning in predicting risk based on observations. Say if we see several steps in the path of an attacker, for example, we can reasonably predict then that other events or alerts will be happening. So machine learning really can play a role across the spectrum of activities for security practitioners, from detection all the way through investigation and ultimately incident response and remediation. That's a great question. All right, so anomaly detection, it only identifies different things. And if you want to be able to detect the known, then you'll have to look somewhere else. There's another challenge with anomaly detection and machine learning in general, and that has to do with the models. If you remember, we talked about training models based on data sets, and then those models are used to identify patterns in future data or make observations about those data sets. When machine learning models generate a finding or an observation, those models are largely opaque, which means you can't see into them. And so this is a caution around the use of machine learning. If you are unclear why a machine learning model surfaced an observation, a prediction, or a finding, that can make it difficult to understand why did this happen? Is this important to me? Is this relevant to me? It's one of the things we were careful to do at ThreatStack, which is to make sure we had enough context so that if you're trying to look at a finding and understand if it's relevant to you, you had enough to work with. If you're not getting enough context around findings from machine learning, then it's really just adding to the noise, and it's really not actionable. So this is a definite caution when it comes to using anomaly detection. Right, so we talked about anomaly detection as an easy button and some of the challenges on that front. Misconception number 2 is that you can get by with just a little bit of data. You really do need tons and tons of data to train your machine learning models. Here's one of the reasons for it. ThreatStack is focused on cloud native infrastructure and cloud workloads. And by design, these environments are extremely dynamic. They're constantly changing. Containers are coming up and down. Instances are coming up and down. Everything is very dynamic. If you start to add in things like Kubernetes applications, these infrastructure is also becoming extremely layered, and as a result, increasingly complex. So the data that you're able to get from a security perspective, the telemetry that you collect is also becoming increasingly fragmented. And so you really want to make sure you have as much data as possible from a variety of sources. That sort of rich data from a variety of sources will really help make your machine learning models all that much more effective in surfacing things that are relevant to you. So you really do need a lot of data. So you need volume. Just as an example, at ThreatStack, we're doing machine learning on, at any given point in time, over 1 trillion events in our data platform. And so you really do need, in order to be effective with machine learning, you really have to be looking at a lot of it. But let's not forget about the other V's in the 4 V's of big data. We talked about variety briefly. Because infrastructure is highly ephemeral and increasingly layered, you really do want different types of data, different sources of data. And I would add, it's not enough to have a variety of data or lots of it. Your data also has to be normalized and well modeled. And this gets to something we'll talk about in a little bit, which has to do with preparing for machine learning in general, and that's data engineering. But you want lots of data, you want a variety of data, and you want it to be ready for inspection by machine learning. The other V's are velocity. To be effective and to be able to surface threats as quickly as possible, you need to be able to run your models on data as it's streaming. So that's velocity. It also has to do with the frequency of model training. And the more frequently you can update your models, the better. Again, because things are changing so quickly in cloud infrastructure, you want to be able to do that. And finally, veracity is the 4th V that you may hear referenced sometimes. Veracity speaks to the trustworthiness of the data. If you do plan to roll your own machine learning and use logs and different sources of data, you want to watch out for veracity. ThreatStack does the collection of data, so we are in control of the telemetry from the time we collect it, normalize it, and model it, and make it available to machine learning. So there's a high level of trust in the data, that it's accurate, it's modeled, and that there isn't any data missing. But those sorts of issues with data quality can really impact what you're able to do with machine learning. So it's important that you know well the source of that data. So you don't just need a lot of data for machine learning, but you need to make sure your other V's are covered as well. One of the other misconceptions that I wanted to spend time covering was around the role of human beings when it comes to cloud security and machine learning. And one of the misconceptions is that, you turn on machine learning and your team can go play golf. You don't need them. Patently not true. In fact, machine learning gets better with humans in the loop. So let me explain. There are two ways in which humans can really impact the efficacy of machine learning. And don't worry, machine learning is not Skynet. It is not coming for your job. Even with the best security telemetry, even with the best machine learning models, they can't replace the decision-making ability of people, and cannot replace the organizational context that people bring to the picture here. Remember, we talked about machine learning being able to identify things like what's different, what's anomalous. It doesn't make value judgments. And every organization that is responsible for cloud security, there are different impressions of what's good versus what's bad. And so you do need humans to be able to look at findings from machine learning and establish, is this relevant to my organization? Is this good or bad? Because that can vary from organization to organization. So definitely need humans in the loop when it comes to evaluating what machine learning is telling you about your cloud infrastructure. But there's also another role for humans, and that's earlier in the process, even before machine learning is generating findings. If you really want to be effective with machine learning, your models have to reflect combined expertise from security and cloud infrastructure experts. At ThreatStack, we got our experts involved very early in the process. As you'll find out in a few minutes, it becomes very important in terms of, number one, what data you collect, what features or dimensions you want to leverage when building your models. And so it's important to get experts involved up front if you're trying to build machine learning for cloud security on your own. So definitely leverage the experts. It is simply not true that machine learning can be turned on and you don't require people to interact with it anymore. Instead, it is better to think of it this way. Machine learning is a force multiplier. Machine learning helps to automate things that are very human intensive. So one person can do the work of many. And a better way to think of this, I believe, is that if machine learning is automating some of the things like detecting anomalies, providing context to help with triage and investigation of findings, then that frees up your team of security analysts and experts to focus on higher value activities. So it's not like people will be replaced. They can do more and be better at their jobs and then focus on those higher value activities. If you're curious about this image, if you Google force multiplier, you get a lot about hydraulics and Pascal's law. So I stuck that in. But at any rate, the idea here is machine learning is able to allow one person to do more and do better at their job. The other thing to point out about machine learning, and I actually think we touched on this just a little bit earlier, is that machine learning is really great at decision support, right? And I would say machine learning and analytics more broadly. There are many, many decisions in this whole life cycle here for which machine learning can be helpful. We've talked about detection and using machine learning to detect anomalies. That's a really good use for it. We've talked about machine learning as being helpful for providing context when you're looking to take a look at alerts, investigate alerts, and reduce the mean time to know. But machine learning also plays a role much deeper in the cycle here, and that is around acting on findings, acting on behaviors that are either out of normal or somehow sketchy, because you can automate remediations and ultimately, I think, predict risk based on your observations of activity in cloud infrastructure. And again, machine learning plays a role in helping provide feedback from users back into detection and analysis, so that when you're taking actions on findings, your models are getting better over time, so that the number of findings shrink to something that's more relevant or increasing relevance over time. And so this is a good time, I think, to call out something that we believe very fundamentally. Machine learning isn't about reducing alerts or reducing findings. I hear that a lot in the market. Turn on machine learning and you'll get fewer alerts. Data is always good. Machine learning really should help you make better decisions around which alerts you want to focus on. It should help you refine your view into what matters to you. But if you're using machine learning simply to reduce the number of alerts that are generated, then you are most definitely missing something. So machine learning should be your guide to what's important. Quick check on questions. Don't be afraid to ask questions if you have them. Okay, so we've talked about some of the misconceptions in the market around machine learning. It's an easy button. You just turn it on and go. There are obvious problems with that in that it will detect unknown behaviors, but perhaps there's some known behaviors which you might want to be thinking about. We talked about the amount of data that you need, the veracity and the velocity of data that you need to process. And so you definitely need lots of it, and you need to spend some time doing data engineering. And finally, we talked about humans and their role in machine learning. You can't take humans out of the loop. In fact, human input, human expertise makes machine learning better over time, both as a detection mechanism and ultimately as a way to remediate risk. So how do we deliver on this promise then? Well, we've got some thoughts, as you might expect. First, you want to collect the right data. We talked about the dynamism that exists in cloud infrastructure today. I would posit that this is a really good start. You want to be able to collect data from each layer of the cloud infrastructure stack. So you want to be looking at data that's coming from your service layer API. What are users doing in your AWS console, for example, if you use AWS? Are they standing up instances in regions that you didn't expect? Are they using keys in a way that is abnormal? This is true across every layer of the cloud infrastructure. You want to be able to look at each, not only each layer independently for behaviors of interest, but ultimately you want to look across these layers as well. There are increasingly sophisticated attacks that span various layers of your infrastructure, and machine learning can be enormously helpful in correlating across these layers to give you a full picture of the path of the attacker. So make sure you're collecting the right telemetry first, and again, lots of it from various layers of your cloud infrastructure. The other thing we learned, and this is important as well, is even before you embark on your machine learning journey, is that you invest in data engineering, that you have to be able to prepare the data so you get all of the V's that I talked about earlier. You want to make sure that you can process this data in a high velocity way and at scale. So we built out our pipeline for getting data, event data that we collect into a data platform, which really accounts for 50 to 60 billion events per day. So you want to do this at scale and with reliability. Some of the other things that we learned have to do with performance. How you land that data and organize that data in your data lake really matters when you start to run machine learning models against it, primarily from a performance and a cost perspective. So think about how you want to organize your data when you want to start to ask it questions. You don't want to be spending a lot of CPU on dimensions or features that are not of interest. You're going to burn cache and you're going to burn up a lot of compute. We also learned along the way that when you're dealing with big data, it is very helpful to set up secondary storage solutions so that when you generate findings, you grab context, you can stick it somewhere so that it is readily available to users on demand, either through UI or API. So as you're crunching through big data, you can save stuff off that is meaningful and important so users can look at it in a much higher performance way later. We also learned that model management matters. At least in the threat stack example, we're running multiple models for each of our customers. And so the ability to update them independently, the ability to have each of those models learn and get better over time requires automation. So definitely invest in data engineering for cleansing of your data, normalizing of your data, and managing your models. The other thing we learned, and then I'll move on, is that it's important to bring in security experts early and often in your machine learning journey. Security experts can be helpful to you in identifying which features you want to search on. This is useful not only to identify what would ultimately be useful to you in an investigation, but also can be helpful in terms of minimizing cost and compute when you're running big data jobs. And definitely establish a feedback loop with your experts. So it's data engineers working with data scientists, working with security experts all together so that you've got this nice feedback loop so that you're constantly iterating on your models and refining them so that they're getting better and more relevant over time. All right, we talked about anomaly detection and some of its downsides. Again, it's really good at finding unknown patterns in data, but what it doesn't do well is identifying known patterns in data. So our recommendation is that you leverage machine learning and another detection mechanism like rules. Rules really are signatures. They're ways to classify events that are coming in. And rules can help to codify domain expertise. They identify known behaviors. And again, known behaviors can be risky and you want to be able to make sure you flag them. If you're only seeing anomalies or unknown behaviors, that can be problematic because normal is not always okay. So in combining rules and machine learning anomaly detection together, you're ensuring coverage of both known and unknown behaviors because the things you're looking for really do span a lot of different use cases. There's some known things like proof of monitoring from a compliance perspective, good basic hygiene around identity and access management, access to your workloads. These are things you know about and definitely want to flag when they're happening. Likewise is true about unknown risks. There's new users and services that come up. These could be anomalous, but not necessarily risky. But there are definitely attacks that are anomalous you want to give visibility to. So your detection mechanisms should span both known and unknown so that you're making sure you identify all the risk that matters.
Hey, Chris, really good question here from Brian, if I can jump in.
Sure.
Brian's asking, are rules and machine learning mutually exclusive?
Oh, a good question. No, not at all. In fact, I think it is important to have rules and machine learning working side by side. They don't have to be intertwined. You can certainly use rules to detect known behaviors and anomaly detection to identify unknown behaviors. But I think when you get the most benefit from both of them is when they're working together. Let me give you a quick example of that. If you're using anomaly detection to identify unknown behaviors of interest, the ability to highlight that behavior as an anomaly and then create a rule for it is really interesting, because you can say, hey, I wasn't watching for that before. I really think this is important enough for me to watch for it now. So anomaly detection can make recommendations for rules that should be in place for things that you should be watching for. So machine learning and rules can work independently, but they're much better or much more effective when they're working together. Yeah, that's a good question. All right, so here's a quick example of what I mean by the benefit of looking for both known and unknown behaviors. You might be seeing some commands that are being run in your production environment, and they're perfectly okay. This is fairly typical, by the way, what we see people in their build environment managing different versions of Python, for example. So we could see this behavior where a user called app user ran Python 2.7, and that's totally fine. Now, I'm often asked the question, hey, if all you're doing is detecting anomalies, can't you do that with a database lookup? A fair question. The answer is no. Well, you could, but it wouldn't be nearly as effective, because if I'm storing this whole path in a database for this first example, and then I'm doing a query to see if a certain behavior has ever run, you wouldn't find something where the path has changed, right? So machine learning can really help you identify, hey, here is something which is different, and it will actually tell you how different it is. So in this case, we might say this running of Python 2.7, it seems to be okay. It's different than the one above, but not terribly different based on the anomaly score. So I think it's all right. Anomaly detection, though, can also take into account multiple dimensions. In this case, we see that the user is different, and I might detect that the anomaly score for this user is much higher. So it is quite odd for C-Ford to be running this, and it might be something that I want to look at. So that's where anomaly detection really shines. Now, if you ever see something running from the temp directory, that's probably not a good thing, and you don't want it to happen. So this is a case in which you might want a rule. You don't want to rely on anomaly detection to surface this. You always want to know when you have executables running from your temp directory. So a combination of rules and machine learning can be very effective here. All right, we talked a bit about this already, and so just to close the loop, machine learning is not coming for your job. We still need security practitioners. We still need security experts. We definitely want to leverage human expertise when it comes to machine learning and cloud security. Experts can be really helpful in even before you start thinking about technology. You want to think about what problems are you trying to solve with data. What data best aligns, what data set best aligns to the problem that you're trying to solve with machine learning. And again, humans bring a lot of context around what's meaningful and what matters to them, including security best practices. And we've talked a little bit about rules already. Understanding of security best practices are things that can be codified specifically in rules. So you can see all these things starting to work together in a really meaningful way. When you're engaging your experts to embark on this journey, make sure you bring in data scientists, data engineers who can help make sure that you get the right data, lots of it, and at high velocity, and cloud security experts. It is great to have both a view on security and cloud infrastructure, because cloud infrastructure is, as we said, highly dynamic and increasingly complex. So when you're bringing humans to bear or engaging your experts, make sure that you have a feedback loop in place so that you can look at the output of machine learning and make it better over time as your environment changes and as your policies change as well. Ultimately, what we want to have here is a virtuous cycle. All of these things we've talked about working together: telemetry, that's data; rules for classifying that data in a highly precise way; machine learning that can help you identify unknown behaviors of interest, whether it generates an alert or whether you want to create a rule for it. Machine learning is helpful on that front. And human experts that then are interacting with the findings from machine learning so that the models get better and better over time. And implemented properly, this flywheel starts to spin so that the findings you're getting from your cloud security solution are getting better and better and more relevant over time. And this can only happen if your data, your rules, your machine learning, and your experts are all working in concert. So thank you for indulging. I hope you found that useful. As you might expect, ThreatStack has been investing heavily in machine learning. We have an announcement coming in early November. If you want to learn more about it, visit www.threatstack.com or look me up, and I'd be happy to answer any more detailed questions for you offline. It looks like we have a little bit of time to spare. So Mitch, I'll throw it back to you and see if there are any questions that we want to answer.
You bet. We've got some really great questions. Let's see, the first one here, or I guess the next one, is from Paul, who asks, what sorts of factors go into algorithm selection?
So he's talking about algorithms that are used to train machine learning models. And that's a great question. My answer is that it depends really on the problem that you're trying to solve. So start there. It depends, what you're trying to achieve, what outcomes you're looking to achieve, and how much data you have to throw at it. I'll use a very simple example. There are algorithms out there that are easy to get started with. I'm thinking a nearest neighbors algorithm, or KNN. This is used for detection of anomalies and clustering. Nearest neighbor works really well when you have lots of data, but if there is a problem with the veracity of data, it can be challenging. So we really want to start out with an understanding of the problem that you're trying to solve, how much compute, how much data you're willing to throw at these algorithms, and that'll help guide you on the path to algorithm selection. That's a good question. I forget who asked it, Dave, I think. If you want to catch up, talk to our data science team offline, be happy to set up a call.
Okay, excellent. Next one is from Daniel, and Daniel asks, machine learning requires complex skills, in particular in the security space. Are there any out-of-the-box solutions that leverage machine learning but transparent to the user?
But transparent to the user. Well, for sure, there are lots of out-of-box solutions that leverage machine learning. Yes. Is it transparent to the user? My guess is that if you're using machine learning as part of your cloud security solution or security solution in general, that the marketing team has gotten a hold of it and is talking actively about machine learning. I wonder if Daniel's referring to the models that are in use. I'm not sure. But there are plenty of out-of-the-box, off-the-shelf solutions that do leverage machine learning. As I mentioned previously, do be careful about some of the promises that you hear from vendors around machine learning, particularly if you hear the word easy, no humans involved, set it and forget it kind of thing. Be skeptical.
That actually ties perfectly into the next question. I think you maybe have partly answered it. Coming from Rebecca, she asked, that seems like almost every security product on the planet says they're using machine learning. How can a layperson tell if a vendor is really using machine learning versus just hyping that they have machine learning?
Oh
What
boy.
questions would you ask a vendor? Maybe I should kind of help Rebecca with that question a little bit that way.
um, yeah, Rebecca, thanks for your question. The the way to tell, I think, if a vendor is using machine learning properly is it's all in the results. There are many ways to measure the efficacy of machine learning over time, but I think the benchmark that I would think of is, um, are you seeing everything you need to see? So is it surfacing all of the risk that you care about in your infrastructure? And are the findings from machine learning both timely and are they relevant to you? That's how I would measure the efficacy of machine learning inside of a vendor product.
Good. Given that you really are implementing machine learning and in your experience, that's a great insight. Thank you a lot, Chris. Next question we have is, I already collect a ton of log data from my cloud infrastructure. How can I use machine learning to get more value from that data?
Well, you absolutely can. Depending on the source of the data, again, I'll go back to some of my earlier comments around data engineering. You will get maximum benefit out of the data you collect if you are able to apply some time to normalizing and modeling that data so that you can really interact with it. You want to make sure that you achieve high veracity of the data source. I'd be happy to talk with this person offline. Give me a shout. We can talk more about the sources of the data that you collect. It occurs to me, something we talk a lot about at ThreatStack is, do you want to be a secure company or do you want to be a security company? Working with big data can be daunting. And it requires a very specialized set of skills, as we've talked about. So if you have the resources and the know-how to be able to approach machine learning on your own for looking at that log data, go for it, absolutely. But what we found is that customers spend an awful lot of time and money really focused on security in and around big data, when they'd be better off partnering with somebody like ThreatStack who is doing the work for them. But it's a good question. You can absolutely make use of machine learning. I would focus first on ensuring that the data you're collecting, there's enough of it and it's properly prepped for getting maximal benefit out of your machine learning models.
Very good. Thank Venkat for his question. That was his last question that we sent, or that we went over. Next question, there's a lot of questions about applications of, is this a good use for machine learning? Colleen asks, would machine learning be able to find scenarios when a system is being spammed with requests or consequent requests, e.g. requests for, and I'm not familiar with this acronym, MSI, SDN, number ranges to identify things like fraudulent activity. Thoughts on that, Chris?
Yeah, I think the short answer is yes. Machine learning can be really effective in identifying outlying conditions. And I'll use ThreatStack as an example only because I'm familiar with the types of data that we collect. But we have visibility into networking activity. We have visibility into commands and executables that are being run in your infrastructure. So machine learning would help us identify if there are outliers in terms of executables that are running, requests that are being made. And so if that behavior is somehow not normal, then absolutely anomaly detection would find it I would also suggest that having some basic rules in place also would help you identify when things are happening that shouldn't. So there's multiple ways in which you could go about that problem. But yes, deep visibility into your infrastructure is a prerequisite to be able to surface that sort of spamming behavior. Absolutely.
Very cool. Edward has got a great question. Talking about, the dreaded false positive, right? The bane of every security professional's existence.
Yeah.
Can you talk a little bit about how machine learning might be being used at ThreatStack to help with that problem with false positives?
Sure. I think we talked about this earlier in the presentation, but let me tee it up really briefly. If you're using machine learning in other security contexts, like malware detection, you have a stronger idea of good and bad. A malware signature is, you can reasonably say, is always bad. With behavioral analysis that ThreatStack does, that good versus bad can be a little bit more nuanced. And so what we do at ThreatStack is to make inferences about what might be most relevant to you. And it's based on a number of factors. I mentioned anomaly score earlier. So we'll set thresholds that will only show you things that are very anomalous or very weird in your infrastructure. I think false positives is, again, in cloud security, a good versus bad can be kind of squishy. And so I think the way that you can best get around that is to use machine learning to suggest behaviors of interest, and then use rules to alert on those behaviors of interest. And so you're able to tune using rules what you really want to know about right away. It's the kind of thing I want to be woken up in the middle of the night to look at this, and use anomaly detection to inform those rules. So it'll identify things you should be thinking about, but won't wake you up in the middle of the night. The other thing around false positives is you definitely want that feedback loop going, so that at day one, you're identifying anomalies, you're using rules to refine what you want to see, but your models should get better and better over time as well, and more relevant to you. So that incorporates organizational context, right? It incorporates user actions. So user actions that are making models better and more relevant to you. So in that way, false positives go down over time.
Mm-hmm. I can't speak for ThreatStack, but my experience with machine learning AI is that also that response saying that this is a false positive, this is not. That is part of the learning algorithm can happen from our interaction with machine learning algorithms.
Sure.
Eventually, and now it can detect those with large enough data set to do that. So it sounds like you're validating that as well.
That's a great call, Mitch, and honestly, that's why we at ThreatStack believe you should have multiple models running for each of our customers, because what matters to them is different from customer to customer. And so updating, one master model, it won't work for everyone. And so we're able to do that on a customer by customer basis. Yeah, these are great questions.
Yeah, they really are. They really are. I want to ask this question from Vlad. You may have asked it or answered it already, but I want to give you an opportunity to respond if there's anything else you want to add. He's asking you to elaborate on normal behavior detection, meaning which way would machine learning distinguish points of concern? Are there certain use cases you can provide? You talked a bit about that already. Is there anything based on Vlad's question you might want to add, or you think you've covered it?
Well, I can certainly provide some additional examples. Let's start with user behavior. There, again, from organization to organization, what is deemed okay can be different. One organization's good might be very bad in another organization. So let's talk about user behaviors. Someone logging into a container in your production environment might be something that is very normal in your environment. We recommend against it, of course, but it might be very normal in your environment. You still want to have rules that identify that behavior despite the fact that it might be normal. And so rules can highlight that situation for you and in fact prove that you're monitoring for such things. So that's known behavior. Anomaly detection and machine learning comes in where you have a user logging into a container or an instance that they don't typically, or they're running commands that they don't typically run. So while you have known bad behaviors that you want to track, anomaly detection comes in at identifying those behaviors that are somehow outside of that normal baseline. And there's plenty of examples of this outside of user behavior. You might want to look at network connections to identify workloads that are making connections out of your infrastructure that are atypical. That's certainly a sign of data exfiltration. If you have a workload talking to a known command and control server, those are the sorts of anomalies that you want to be able to surface. So these things, rules, machine learning, need to be working together.
Great. One last question, lightning round question, if you can answer in about a minute or so.
Okay.
Interesting question from Colleen, who asked a prior question. She said, would you use machine learning? Would it use applications like Elasticsearch? Would machine learning use Elasticsearch? Maybe you can talk about how machine learning does process the data and if something like Elasticsearch would fit. You have a minute and a half. How about that?
Oof. Well, does machine learning use Elasticsearch, or can machine learning be used to identify problematic behaviors or insecure behaviors in and around Elasticsearch? In our case at ThreatStack, we do use Elasticsearch in our infrastructure. It isn't used for machine learning. In fact, we index events so that customers can do deep investigations by searching through event data. But we've got a different data pipeline for feeding data to machine learning models. We certainly can monitor instances or clusters of Elasticsearch for behaviors that might be a little problematic or sketchy.
Fantastic, great answer, and within the time limit. So thank you so much, Chris. Fantastic presentation. Really thank you for that, and congratulations, great job. And of course, we thank our audience, our participants, for their awesome questions. They were really good. I sure learned a lot today from all of you, so it was fantastic. So let's take care of a little bit of housekeeping. I know folks would like to learn who those winners of the 4 gift cards are. And the 4 folks who've won are Bill T, Deborah W, Shane P, and Stefan F. The folks here at securityboulevard.com will get a hold of you, let you know how to get a hold of those gift cards. So please join me in thanking Chris Ford, VP of Product with ThreatStack. Again, fantastic job, Chris. I can't wait to be on the next webinar with you. So
thanks, everyone.
And please check out securityboulevard.com for other great webinars from folks like ThreatStack. And we look forward to you participating in that way. You know what? You've spent an hour of your time with us. It's extremely valuable time, and we're honored that you would spend it with us. We really thank you for your time today. So have a great day. Be well, be safe, and be careful.